let's look at a few, I think, key things in the urban and rural sectors, right? So, you know, all of these numbers are pretty scary, right? So when I look at water, and we'll talk about water for a second, look, the population is increasing, there is more migration into urban areas, and that creates all kinds of problems with regards to water, right? So the very first problem is water supply, okay? So I have, for instance, if you take Chennai, and I'm very familiar with Chennai, so I'll use that as an example, but you could look at other places as well. Chennai gets its water primarily from, most of India gets its water from the monsoonal rainfall, right? And our monsoonal rainfalls always, they sort of, you know, high intensity, short duration. So if you look at Chennai, you know, our entire rainfall typically happens in the October, November, December, maybe January kind of months. Normally it's about 2.5 months of intense rainfall, right? So we don't have rain throughout the year, right? There are a few rivers that run, but many of them are rain fed. And therefore it comes, the amount of water you have comes down to how efficient are you in storing the water when it rains, right? We have a few reservoirs, right? We have this Chembarambakam reservoir, we have something called Poondi reservoir, we have something in Red Hills, some reservoirs, etc. Now these reservoirs have a fixed capacity, right? So they can serve a certain number of people. As more and more people start coming in, right, obviously the amount of water per capita will decrease, right? Add to that the fact that if your monsoons are very intense, right, and so if you have, you know, a slow amount of water coming through a long period of time, then your reservoirs are going to continuously be filled, and so the rate of outflow might be the same as the rate of inflow. You can get to steady states and all of that. But obviously that's far from the case here, right? The case here is that you have a steady outflow. In fact, the outflow is increasing because we are drawing more and more water, right? But at the same time, the rainfall patterns are now turning out to be highly erratic, right? So I guess in your first year or second year, you guys must have, some of you might have been around when Chennai had unprecedented floods. The next year we had virtually no rainfall, right? And so we have to think very carefully about how do we manage, how do we store our water, and how do we then use that water, how do we distribute that water to a population that's continuously growing. All right, given that we don't even know how much rainfall we're going to get next year, right? So it's a relatively difficult problem. One of the problems with the floods was, even though there was a large quantum of water, a lot of it eventually flowed into the Bay of Bengal, right? And therefore, while we can claim that there was so much rainfall, all of that water is not necessarily used for drinking purposes or whatever, right? And therefore, you know, one of the things that a state like Tamil Nadu is doing, right? So what are we doing to mitigate that risk? Right? The fact that I don't know how much rainfall will, you know, I don't know when rainfall will happen, I don't know what intensity, I don't know how much rain I'll get, I don't know if my reservoirs are going to be full. Meanwhile, population is increasing. So what are we doing about it? Okay, so there's something called rainwater harvesting, right, that we did. Okay, so that was one measure, right, saying what rainwater harvesting does is it forces all plots to direct some of the rainwater into the ground, so that at least your groundwater levels get recharged. All right, that's fine, but that doesn't necessarily translate into drinking water. Now, what a lot of people do, most residences do, is we have bore wells. Right, we drill bore wells and we get water out of the bore well, which means if the metro water does not supply water to me, I'm insured because I've got a bore well that I've dug. But actually bore wells are illegal, right? You're not supposed to be digging bore wells because groundwater is not your resource or my resource, it's a community resource, right? So, what rainwater harvesting brings up the groundwater level, but it still doesn't deal with the problem of the source, all right? So, what are we doing about it? Right, so I think the point that Lakshmikant's bringing out is, okay, so let's admit now that surface water and groundwater as far as consumption is concerned are linked, right? So, because we are not able to provide reliable water supply, we have to look at groundwater sources, right? Now, in the past, if you go to the history of Chennai or any other area, the kings in olden days actually had a very cleverly built interconnected system of tanks. Right, here we call them the Erie system. In different parts of India, you probably call them differently. Even places like, for instance, in Rajasthan, where you get very, very little rainfall, they had very interesting ways in which they would manage the infrastructure. So what they would do, for instance, is you would have a series of ponds that are probably at decreasing elevations, and so essentially you have a lot of rain somewhere, there's overflow, it goes to the next pond, that's overflow, it goes to the next pond, and so you have a series of lakes that are filled, and finally water drains out. You give yourselves the maximum probability of catching all of that water depending on the rainfall, and then based on that you actually supply, and population did not necessarily overstrip the ability to supply. So you had a self-functioning system. What's happened in recent years is that we've had a lot of development happen, and a lot of that development has happened in these natural waterways, right? As a result of which, what has happened is the water flow path right, has been blocked because you've actually built a multi-storied building or a whatever, right, and that therefore has led to some fluctuations in water supply. One of the things we've done, because now we have the technology, we have the electricity, is start extracting water from the ground, okay, which is okay as long as the water I extract from the ground goes back in when it rains, and that's where rainwater harvesting and all of that comes in. But one of the factors that mediates all of this is the extent of pervious or impervious surface that you have. So if I develop a certain area and I put in nice sort of concrete, asphalt, road, sidewalks, etc., so the surface is impervious. When it rains, the water is going to run off elsewhere, right? It's not going to seep back into the ground where I am living in, where I'm drawing groundwater from, right? So the whole notion of low impact development essentially says, look, you've got to develop, but can you develop in such a way that you do not alter certain basic ecologic functions, right? So altering these ecologies lead to both problems, right? They lead to water shortage, right? Because you are blocking waterways, you are, depleting or reducing the ability for groundwater to seep into the ground. But they also, paradoxically, why they also facilitate drought, they also facilitate flooding, right? Because it's because these waterways are blocked that water is trying to flow through gravity and it sort of comes against a blockage, so it keeps rising and that area gets flooded. Right? So both droughts and floods are sometimes a consequence of relatively poor, not poor planning, but rampant development, right? And why do we have this development, right? We have this development because you have people from rural villages just sort of coming in, right? And you need to build houses for them, you need to build schools, you need to build offices, right? There's so much development that needs to happen. We are a developing country. The auto industry wants a place to manufacture something. The IT industry wants a place so that they can set up their IT offices. We have a development need and that needs to be met, right? And it's a rapidly growing development need. And by trying to meet that, sometimes you lose sight of some of these ecological functions, right? So one of the things that we are trying to do on the supply side, right, in Tamil Nadu is desalination. Right? We're blessed with a coastline and we're saying, okay, let's just take water from the sea, right, and desalinate it. Not a bad idea, except there are a couple of issues to think about, right? First is desalination is very expensive, right? The reason it's very expensive is also because it's highly energy intensive, right? So it's not sort of a simple water filtration technique. It's highly energy intensive, all of that. It's also a bit, environmentally unfriendly. Right, because one of the things you got to think about is desalination. Essentially, you take water and you really push it through these small pores so that all the impurities stay behind. It's what we call brine. What do you do with the brine? Right, you take the brine and you dump it back in the ocean, and that has consequences for marine life in the ocean. All right, so there are some issues with desalination, but desalination is a good risk mitigation measure because whether it's going to rain next year or not, right, chances are that the ocean will still be there, right, with enough water for me to desalinate. So if you look at Tamil Nadu, for instance, we've said, look, our rainfall patterns are very erratic. We don't know where to store water. They've already built 200 million liters a day worth of desalination. There are some plans to build about 550 million liters a day more capacity. Right, but even that won't supply the entire city, right? That supply half the city. So water supply, right, is a big issue because people are going in. But then the problem is after I supply water, there is this whole matter of water distribution. Water is a bit like power. There's generation, transmission, distribution, right? You don't generate water. I mean, you can if you look at desalination as generation, but otherwise you catch water. There's a reservoir component, but then you have to distribute it. All right. Here is where there are tons of problems. All right. So if you look at the water infrastructure, and here, I'm going to come to your point. There are two terms that are very often used called UFW or NRW. NRW means non-revenue water. UFW means unaccounted for water, right? They both mean more or less the same thing, and the logic is simple. Somewhere near my reservoir, I have sent in X liters, million liters, whatever of water through the pipe. All right. How much of water do I actually get at the other end? All right, and what you get at the other end is sometimes a small fraction of what you sent in, right? So where is that water going? Okay, so there are two things that, or there are a few things that could happen. Sometimes if you have open channel flow, there could be some amount of evaporation, right? There are evaporative losses, but these are generally in the 4-5% kind of range, right? These are not in the 20-30% kind of range. Okay, so what else is happening, right? One other option is that there are leaks in the pipe. Okay, you've got very old infrastructure that's rotting, there's leaks in the pipe and water is essentially just going nowhere, right, going into the ground. And then the third possibility is that people are actually stealing water. Just like we talked about people stealing power, you have people stealing water, right? Putting their, linking into the mains, etc. Right? Either ways, you have water that's unaccounted for or non-revenue water. Okay? And that upsets the overall water balance. At least you should have, you should supply water to everybody, but you should at least know where that water is going. All right? So there's a distribution problem, okay, or a transmission problem. In distribution, right, we have a problem with regards to pricing, right? Do you want to now talk about what you wanted to say then? Okay. So essentially, what do all of you pay for water? Anyone know? In your houses, wherever you are, roughly what are you paying for water? Okay. How many of you pay a fixed fee for water versus a fee based on how much water you use? How many of you pay a fixed fee for water, irrespective of what you use? All right. How many of you think you pay a how many of you don't know? That's fine. If you don't know, go and find out, right? Call your parents today, right? How many of you pay a variable fee? Okay. So yeah, because in Germany you guys pay per use. So in most cases in India, we're still paying a fixed fee for water, right? So irrespective of how much water you use, I'll charge you a certain amount per month. And that amount could be as low as 50 rupees, right? 50 rupees a month per household, you use as much water as you would like. Now this leads to two problems, right? Just like with power, right? What is my tendency with regards to water? Waste water, right? Is there any cost to me of leaving my tap open all day and coming back in the evening and shutting it down? Nothing. I'm not paying anything extra for water, right? So that's one set of problems with having this kind of charging regime. The second is how much money is the Metro Water or the Water Board making? The Water Authority. So in Chennai, we have the Chennai Metro Water Sewage and Sanitation Board. How much money are they making? Right? Very little, because you're consuming a ton of water, you're paying them 50 rupees a month, right? And so their finances are relatively low, which means they don't have the money again to start fixing these leaks, right? And so you have the whole vicious cycle coming in. So the metro water system, for instance, is, continuously you expect some amount of money to come in from the state government's budgets, etc., to fulfill your daily operations. So when you talk about desalination, etc., none of this comes from their own pocket, right? That's funded by somebody. One of them was done on public-private partnership, etc., right? Which means it makes it difficult to improve on the water infrastructure, right? But there's a big, so with power, I can change the power tariffs relatively easily, right? With water, it's a bit more difficult. What do you think that is? Why can't I just double or triple the water tariff? Harsh? So big issue is political, right? Because there is still a belief that water is a basic human right. Everyone must be supplied with water. Water is sort of, it's God's gift, whatever. So not only should everyone be supplied for water, there is in some cases a belief that water should be given free for everybody, right? And therefore, when you start pricing water, right, it goes down very badly from a political perspective. People start sort of arguing, saying, how can you price water, right? Is it right to price water? And of course, in politics, these are things that opposition parties will like to jump on. And so hiking tariffs is a very, very politically fragile kind of game. From an economics perspective, the answer is actually quite simple, right? Anything that is scarce or anything that is finite, right, must have a price, right? If it's infinite, then it doesn't have a price, because we can go and get, however much of it we want. But if it's finite, it must have a price. And water, potable water, we all know is finite, right? There is a certain fixed amount of water there is, and therefore there must be a price. And the lower the quantity of water available, the higher the price must be, right? Sort of what the economists will talk about. But that's of course difficult. So the water sector has all of these challenges, right? We may not be doing a great job of managing our reservoirs and catching enough water for storage, right? We may not be doing a really good job of distributing that water, right? Because all these pipelines are leaky. We may not be doing a great job of pricing the water and reducing the waste at the end user level, right? We may not be doing a great job of controlling or regulating or monitoring groundwater levels, because groundwater levels have all kinds of impacts. Your soil stability changes if the water level goes down, which means the foundations on which your houses are resting, right, might no longer be as safe as you might have thought they would be, right? So all kinds of ecological balances are there. And the problem is the metro water bodies don't have the money to do anything about it, right? And don't have the authority or don't have the political willingness to do much about it, because water is such a sensitive subject. Although, ironically, okay, who does not get water, right? Which section of society normally doesn't get water? Poor people normally don't get water. The reason is all of us have water connections, right? When your apartment or house got built, you got a water connection. Now water may not come every day, right? But you do get water. But poor people living in slums have no water connection, right? So where do they get their water from? So there might be some public taps, right? But if you don't have public taps or the public taps run dry, what do? Right? You get a water lorry, right? You see water lorries everywhere. There's one filling station right outside IIT, so you'll see actually a bunch going on the road. How much does water in the water lorry cost? Per liter. Or whatever, per kiloliter, whatever. So normally you're talking about at least a 10x difference between what you're paying to Metro Water and what you're paying to the water lorry. So the irony of the matter is, I'm a relatively well-to-do middle class person with a water connection and I pay a pittance. This supposedly poor person with no money pays 10 times what I do, right? And yet you cannot ask me to pay more for water, right? So this is sort of, I think, one of the, so some of the things that we have to get our heads around is that people talk about the reason that you cannot increase water prices is because the poor cannot pay, right? So they come and say people like you can pay, but the poor cannot pay. But if you open your eyes, it turns out that not only can the poor pay, the poor are paying. Right? While you and I are sitting happily paying our 50 rupee equivalents, right? Poor people actually are paying for water tanker loads because there is no other water available. So we really have to think carefully about the economics of water supply, right? So water supply, I think, is one sort of very important thing to think about. Yeah.
Why not a hybrid pricing for a fixed amount?
Correct. So there's been all kinds of, so there's a lot of literature on pricing, right? So for instance, people talk about what we call telescopic pricing, where we say, the first few kiloliters, right? So the United Nations has, a number on the amount of water a human being needs. Anyone know that number? 135 liters per capita per day. It's being debated, looks like it's a bit of an inflated number. I think people can live on 100 whatever. I actually heard once that Hamburg delivers about 80 liters per capita per day and they seem to be very happy. I'm not quite sure if that data is true or not. But anyway, I think whatever it is, right? So let's take 135 liters per capita per day, all right? So one view is to say, take a family of 4 or family of 5 because you have, parents, 2 children, maybe 1 grandparent who's staying with you, whatever, right? So family of 5, multiply 135 divided by 5, approximate it to about 700, all right? So let the first 700 liters that I supply per day, right, be either free or at this 50 rupees or at some nominal rate. Beyond that, let's start charging, all right? And let's start charging telescopically, which means I'll give you a rate from 700 to 1000 and then that rate will be much higher from 1000 to 2000. What's the logic? The idea is that people who are using more and more water probably are people who are living in fancy homes, need to water their gardens, need to water their cars, etc. and therefore they pay more, right? And others essentially are living in these sort of small families, etc. So we've tried that out. The problem is sometimes you have a few water connections for a large number of people. Right, so there's actually one water tap which 15 people are using. It looks like they're consuming a lot of water, they get put in the highest band. So that's one type of pricing. That's what we call telescopic pricing. Another type of pricing is just demographic, right? You identify rich neighborhoods and say you guys pay X. You identify poor neighborhoods and say you guys pay Y. Now the problem is that neighborhoods are not so nicely drawn, right? So you might have slums at the fringes of the rich neighborhood and so there is some thinking on pricing, right, which I think is, which we sort of need to think about, and there are also these hybrid things possible. But I think the point that Tilman made was, is a good one, which is, why do we need to constantly generate new water, right? So why can't we just recycle water? And today, most studies show that if you consume 100 liters of water, then 80 liters essentially goes into some kind of drainage system. So if you look at where you consume water, right? So there's some amount of water that stays in your body, right? So you drink, etc. But a lot of it is if you're washing vessels, that goes into the drain. If you're bathing, that goes into the drain. Even when you go and urinate, right? That's water going back into the drain, right? So roughly about 80% of water goes back into the system, okay? Possibly more. I'm just giving you a ballpark figure. And that water can be treated, right? Most of you have taken some course or the other on environmental engineering and you know there are all kinds of treatment system, primary treatment, secondary treatment, tertiary treatment, sewage treatment plants, all of that. And generally what we seem to be able to do is recover again about 80% of that water and actually treat it to very high quality, right? So if you say, if I supply 100 liters, 80 comes back into the system and I can recover 80% of that, that means for every 100 liters that I supply, I should be able to put 64 liters back into the system, which means tomorrow morning, I only need to supply 36 new liters. I don't need to supply another 100. right? So every day I essentially need to supply 36 more liters, because 100 liters going into the system, about 64 comes back, right? Which means I've brought down my water supply requirements by a third, right? And it's relatively, and there's all kinds of ways of doing it. You have these large centralized sewage treatment plants, right, where you bring all the sewage, you treat it at scale and you distribute it. If you go and talk to Professor Ligi Philip and others, they'll talk about all kinds of decentralized plants that can be installed at an apartment level, at a community level, right? So you pick and choose what you can do. So I think this is a very, very important option, right? What's happening today in India is we are doing it a little bit with industry. Right, so there is some wastewater that is being treated and supplied to industry that requires water. So the leather industry, the textile industry, sometimes the automotive industry, if they want to use water as a coolant, etc. Right? Why do you need drinking water for that? Right? You can use recycled water. So there are about, I think about 90 plus 90, I think about 180 odd million liters a day in Chennai that's sort of going there. Why can't we use that? For domestic purposes? Most of the problem is psychological, right? Question is, people are saying, look, what am I drinking? Am I drinking my own wastewater? How effective is that? Okay, and that is obviously a big cultural barrier to break. But Singapore, for instance, does that all the time, right? So Singapore actually, and they've actually branded it, right? They've actually got something. If you go to Singapore, you can drink what's called new water. Okay, that's what they call it, right? They say, they don't call it recycled water, they call it new water. Right, and so Singapore essentially, any water that you do, and they actually sell new water bottles, right, which is completely 100% recycled water. But even otherwise, in Singapore, you can open the tap and drink water, right, because it's sort of well treated and all of that. 3% of that water is recycled water, right, and nobody has a problem with, or I mean, I've been to Singapore a few times. I'm still alive. Okay, so you can certainly drink that water. We also do something very similar at IIT. I don't know how many of you know. We have a treatment plant at IIT. It's sort of on the way to the research park, past Mandak Hostel, right? And that treatment plant treats a lot of our water, right? As most of you know, some of the new hostels, etc., that's what is being used for flushing the toilets, etc. The metro water supply doesn't go in to flush the toilets. We recycle our own water. We have a dual piping system, so there's another set of pipes that come in, and that's how you flush your toilets, etc. But there is some amount of that water going into the lake, right, and some of which is actually then making its way into the system. Okay, now of course in India none of us drink out of the tap. We still boil the water or purify it, reverse osmosis, ultraviolet, whatever it is. But the feed water going into that, particularly if you're on campus, some of that is actually recycled water, right? And judging by the fact that over the years attendance is not dropping, right, I assume that it is again not entirely unhealthy for you guys to be consuming that kind of water. Okay, so and therefore what happens is, one, when we had that drought a couple of years ago, right, where the city was screaming and crying for water, we were still watering our entire vast 550 acres worth of campus, right? And we actually had excess water that we were trying to give away, okay, because we were recycling water. So recycling is a very, very powerful strategy, but politically it isn't permeating far enough yet, right, at least in the Indian context. Yeah.
Why do people need to know where the water comes from? For example, in my hometown, I have no clue where the water comes from, but I bet at least 50% of that is treated because it's scarce somehow at that part.
Yeah. So that's a good question, but this is where absolutely. I mean, I personally am of the same opinion, but many people aren't, right? There's a very sort of clear, as a water supply department, you're supposed to deliver a certain kind of water, to my doorstep. Is sort of an attitude that a lot of, non-governmental organizations and others have. And so, yeah. But once you tell them, with social media the way it is, right? So these are things that are again politically sensitive, right? So by the way, a lot of you probably didn't know that this was happening at IIT, right? Right? You knew the recycling was happening, but did you know that it was going back into the parts of it were going back into the system? Okay, beyond the flushing, many people don't know that, right? And that's exactly, sort of your point. People don't really know, people don't really care. But outside, there's always this sort of investigation of what's going on, right? So anyway, so I think that these are, but I think this is the way of the future, right? I think at some point we'll have to put our heads down and say, we have to sort of look at wastewater treatment. In fact, I'm engaged now in also helping Chennai draft a strategy, and this is one of the things that we're thinking that we'll need to sort of put in it as a recycling strategy for Chennai, because how long are you going to go with rainfall patterns being variable and population increasing, right, trying to supply water? All right, okay, yeah, last comment and then we'll move away from water. So it has been tried. See, the thing is, telescopic is fine, but you have to sort of weed out these anomalies. Right? Problem with telescopic, like I was saying, in certain places is there'll be one connection which seems to be consuming a large amount of water, and you really hit them with a large price, but it turns out that that's not one connection, it's a bunch of poor people sharing one tap. Right? So you need to be able to iron those out. You need to be able to say, no, that's an anomaly, we will not charge this telescopic price there. But when the millionaire waters his 3 Mercedes-Benz and Audis and his lavish garden landscape and all of that, then we will actually increase the price that we charge. So there has to be some sort of oversight, governance, all of that, right? So water is a very sort of interesting subject, right? I'm going to move on now because we're sort of way behind. All right, so these are just data, etc. Urban population growth, as you can see, a lot of it is because of urban to rural migration, all of that.